All right, diving in deep today. We're looking at the future of hydropower. Not just your grandpa's dams, but the really innovative stuff pushing this old energy source forward.
Yeah, it's a really exciting time for hydropower.
We've got some great sources today. One's a super detailed scientific journal article about all the latest tech. And then we've got another article looking at the environmental side of things, how hydro fits in with all the other renewables.
Yeah.
So what we really want to get into today is how is this tech being upgraded for a world that's like increasingly using renewables? What's tough about that? And why should anyone listening care, even if they've never, been near a dam?
Right. It's easy to think of hydropower as kind of, well, stuck in the past.
Yeah.
But it's actually changing a lot in really incredible ways. As we move toward more variable renewables like wind and solar, hydropower is becoming super important to balance everything out.
Oh, interesting. So instead of just like always generating the same amount of power, it's got to be more flexible.
Exactly. Think of it as a giant, clean battery for the whole electricity grid. So when the wind dies down or the sun sets, hydropower plants can quickly ramp up their power output. And when we have more renewable energy than we need, we can use that extra power to pump water uphill into reservoirs, basically storing that energy for when we need it later.
That makes a lot of sense, especially with everyone wanting reliable, renewable energy. But I'm guessing this shift isn't, all smooth sailing, right?
Right. You've got a point. A lot of existing hydropower stations are pretty old, and they need some serious upgrades to make them more efficient, make them last longer, and, help them react quickly to the demands of a modern, very dynamic grid.
It's almost like trying to run the latest software on an ancient computer. Sometimes you need a hardware upgrade to really get the best out of it.
Exactly. You hit the nail on the head. And Europe is actually leading the way in this hydropower revolution. They've already used up a lot of their easy hydro potential, and many of their plants are from like decades ago. So there's a massive push to modernize them and squeeze out every last bit of clean energy they can.
So let's get into the details. Our journal article gets really deep into the tech behind this hydropower evolution. I was especially interested in something called the draft tube. Could you explain what that is and why it's so important for efficiency?
Yeah, the draft tube. It seems like a small thing, but it's actually critical. It's the channel where the water exits the turbine after it's spun the generator. And its job is to convert the water's kinetic energy, from its movement back into potential energy. Basically recovering as much of that energy as possible before the water flows back into the river.
So it's all about squeezing every last drop of energy out of the system.
You got it. Researchers are constantly working on perfecting the draft tube shape and how the water flows through it, all to minimize energy loss, even when the plant isn't running at its peak efficiency.
Because sometimes you don't need to use the full power of the plant.
Right. In hydropower lingo, peak efficiency happens at what we call the best efficiency point, or BEP. But in reality, these plants often operate at different levels, depending on how much energy the grid needs. So a lot of researchers focus on making draft tubes that stay super efficient, even when they're not operating at that perfect BEP.
Okay, so how do they actually do that? The article talks about both passive and active control techniques. Can you break those down for us a little?
Sure. So passive control is all about the design of the draft tube itself, like engineering the most efficient water slide you can imagine. So the shape and the curves are all designed to guide the water in the smoothest way possible, maximizing that energy recovery.
Yeah.
Now, active control is more hands-on. It uses external mechanisms to adjust the flow, kind of like having someone there, dynamically adjusting the water jets on that water slide to get the perfect ride.
Now, this flow feedback method, or FFM, really caught my attention. It sounds almost like the turbine is self-regulating.
It's a pretty ingenious technique. It's actually a passive control technique, but it uses some of the water leaving the turbine to create a counterflow within the draft tube. And by cleverly redirecting some of the flow, you can smooth out turbulence and make the pressure recovery better, leading to, a boost in efficiency.
Wow, that's super cool. Sounds like we're just scratching the surface of how hydropower is being reinvented. And so we've seen how engineers are getting really precise with things like the draft tube. But what about the bigger picture? Are there innovations changing, how we even think about hydropower?
Absolutely. It's fascinating how digital technology is merging with hydropower, creating these intelligent systems that are so responsive.
That sounds pretty cool. Can you give us an example?
One of the most exciting developments is the idea of digital avatars for hydropower plants. It's like, imagine creating a virtual twin of an actual power plant, that we can use to like monitor and tweak performance in real time.
A virtual twin, huh? So it's basically a like high-tech simulation that's mirroring what's going on in the real plant.
Yeah, exactly. So using sensors all over the plant and some really advanced data analysis, we can build this dynamic digital model. It can even predict problems, simulate different operating scenarios, and basically optimize everything for maximum efficiency and reliability.
So it's like having a team of like virtual engineers constantly watching and adjusting the plant. Wow. So what kind of benefits does that translate to in the real world?
Oh, the benefits are huge. These digital avatars can really help stabilize the grid by giving us more precise control over power output. And they can react much faster to changes in energy demand, which, helps keep the grid balanced even with all the ups and downs of wind and solar power.
I bet that kind of responsiveness is like crucial to prevent blackouts, especially as we rely more on weather-dependent energy. But let's switch gears for a second. You mentioned before that hydropower plants don't always have to run at a fixed speed. I always thought that was like a fundamental rule to make electricity that works with the grid.
That's how it's traditionally been done, but with all the advances in power electronics, variable speed hydropower is becoming a reality.
Okay, so what makes variable speed technology such a game changer?
It basically unlocks a whole new level of flexibility and efficiency. By being able to change the turbine speed, based on the water flow and what the grid needs, you can make the plant's efficient operating range much wider.
So it's not just about like generating a certain amount of power, it's about doing it in the most efficient way possible, whenever you need to.
Exactly. Traditional fixed-speed plants have a limited sweet spot where they're the most efficient. But with variable speed tech, you can basically move that sweet spot up or down depending on the conditions.
I can see how that would be super useful with all the wind and solar power coming online. Like, if the wind suddenly drops, a variable speed hydropower plant could quickly ramp up its output to, like, make up for it. So are there different ways to do variable speed operation?
Yeah, there are a couple of main approaches. One uses what are called converter-fed synchronous machines, which basically use power electronics to convert the variable frequency power from the turbine to the fixed frequency the grid needs.
So it's kind of like a translator between the turbine and the grid, making sure the electricity is, like, always speaking the right language.
Yeah, that's a good way to put it. Another approach uses doubly fed induction machines, which let us control the turbine speed more directly.
Wow. It's incredible how much innovation is happening inside these hydropower plants. But what about like even bigger, more conceptual changes? I read about some pretty futuristic ideas like underwater pumped hydro and these hybrid systems. Is that stuff really on the horizon?
Those are definitely exciting areas with huge potential, like underwater pumped hydro energy storage, or UPHES. It uses the pressure of the ocean itself as the upper reservoir.
So instead of building a reservoir on land, you're using the vastness of the ocean for storage.
Exactly. And this opens up hydropower to a whole bunch of new locations, especially coastal areas that, maybe don't have the right geography for traditional pumped hydro.
Okay. And what about these hybrid systems? Combining hydropower with like flywheels and supercapacitors seems like a really powerful way to store energy.
It's a really interesting area of research. Flywheels and supercapacitors are awesome at delivering very fast bursts of power, which is perfect for keeping the grid stable when there are sudden changes.
So they're like the sprinters of the energy storage world, while hydropower is the marathon runner.
I like that analogy.
Yeah.
By combining these different technologies, you can create a system that can handle both, short-term and long-term energy needs.
All right, so we've covered all this cutting-edge tech happening in large-scale hydropower, but what about smaller projects? I'm curious how hydropower can be made more accessible to, like, communities and individuals.
That's a great point. Hydropower isn't only about massive dams. There's a ton of potential in smaller waterways, like rivers and streams.
I've heard of small-scale hydro, but I don't really know how it works. Is it just like shrinking down the same technology?
It's more than just making things smaller. There are special technologies and approaches that work really well for smaller projects.
Can you give us some examples?
Yeah, there's a lot of research going on to improve the efficiency and affordability of things like water wheels and, believe it or not, pumps that are used as turbines.
Wait, using a pump to generate power? That sounds pretty clever.
It is. It's called a pump as turbine system, or PT. And because pumps are already made all over the world, repurposing them for hydropower can be really cost-effective, especially for these smaller projects.
And I guess these smaller projects have less of an impact on the environment compared to huge dams, right?
Yeah, often that's the case. But it's important to remember that even small dams can change the ecosystem. Things like disrupting the natural water flow, blocking fish migration, messing with sediment transport. Those are all things to consider.
So it's not as simple as small is always good. You really have to look at the potential impact of any hydropower project, no matter the size.
Absolutely. And it's key to remember that hydropower is just one part of the renewable energy solution. It's not a magic bullet, but it's a valuable tool that needs to be used carefully and strategically.
Okay, so wow, we've covered a huge amount of stuff in this deep dive, from draft tubes to the idea of underwater hydropower. Before we wrap up, I'd like to hear your thoughts on where you see hydropower fitting into the future of sustainable energy.
Hydropower is definitely going to be a key player in the shift to a cleaner energy system. Its ability to store energy and smooth out the variability of other renewable sources makes it a really important asset.
But with all the environmental stuff we talked about, how do we make sure hydropower is developed and implemented in a way that truly benefits both people and the planet?
That's the big question, isn't it? And it's one that needs a very nuanced approach, taking into account the specific circumstances of each project.
We'll have to continue that discussion in part 3. For now, let's take a moment to gather our thoughts. We'll be right back to explore what the future holds for this powerful and evolving energy source.
Wow, we've covered so much in this deep dive, from the inner workings of those draft tubes to some really big ideas about how hydropower can shape our energy future.
Yeah, it's been quite a journey exploring how this, centuries-old tech is getting a modern makeover for a world that's increasingly running on renewables.
And it's obvious that hydropower has, a lot to offer. But as we talked about, there are some serious environmental and social things to think about that we can't just ignore. So, as we wrap up, I'd love to get your take on what a responsible, sustainable approach to developing hydropower would actually look like. That's the million-dollar question, isn't it? We can't just assume that because hydropower is renewable, it's automatically the perfect solution, right?
Yeah.
Every single project needs to be carefully looked at, based on its own specific context.
So what are some of the key things to consider in that evaluation process?
Well, it all starts with picking the right spots for these projects. We got to move away from that old idea of damming up every river we can find. Instead, we should be focusing on locations where the impact on the environment is minimal and the benefits of hydropower clearly outweigh any potential downsides.
So it's about being strategic and choosy, not just going for the biggest or most powerful option.
Exactly. And once you've chosen a site, it's super important to put things in place to protect the surrounding ecosystem. Things like fish passages, carefully planned water releases, and strategies to manage sediment, those can make a huge difference.
It seems like there needs to be a lot of teamwork between the engineers, the ecologists, and the local communities to really get these projects right.
Absolutely. And that collaboration has to keep going throughout the entire life of the hydropower project, from the very beginning planning stages all the way to how it's operated and monitored in the long run.
I'm also curious how all those innovations we talked about, like digital avatars and variable speed technology, can help create a more sustainable approach to hydropower.
Those advancements can play a big role. For instance, digital avatars can help us run hydropower plants in a way that minimizes their environmental impact. By constantly keeping tabs on conditions and adjusting operations in real time, we can fine-tune those water flows, reduce stress on the ecosystems, and even boost the energy output.
So it's about using technology to work with nature, not against it.
Exactly. And variable speed technology can help us better integrate hydropower with other renewable energy sources, creating a grid that's more resilient and sustainable as a whole.
It's really cool to see how innovation in hydropower isn't just about making things more efficient and powerful, but also about minimizing the environmental impact and, maximizing the benefits for communities.
It really highlights how technological progress should always go hand in hand with a commitment to sustainability and a deep respect for the natural world.
We've explored a ton of fascinating stuff in this deep dive, from the nitty-gritty of draft tubes to the mind-blowing potential of underwater hydropower plants. But what really stood out to you? What questions are you left with about the future of hydropower? We'd love to hear your thoughts.
And don't forget to check out the links to the sources we use so you can keep exploring this exciting, constantly evolving field on your own.
Until next time, stay curious. And remember, even in the world of hydropower, there's always something new to discover beneath the surface.